Hi everyone, my name is Umais Siddiqui, and before I actually begin the presentation, I just wanted to mention that I have published the link um, in the spreadsheet where people have posted their timings for the presentation. So if anybody's interested, they can always click on that link and view this presentation. It's published on RPubs, so it's easily viewable from there. And the second thing I wanted to actually mention was that I have all the code posted on GitHub. So, and I have a link to that here in the presentation. So if anybody was interested in seeing that the code for this R Markdown, you're welcome to go and look at that code. Let me just show you that from here. Um, and this is the R Markdown file. And if you look at the code, there's also some inline code that I've done to calculate the IQR, which is the interquartile range, and that's Q3 minus Q1. So um, I've done that inline code within the R Markdown file. So some of that kind of stuff. I mean, if you're interested in seeing, you can see that here. So getting back to the presentation, the problem that I decided to present is problem number 2.15, and you can find that problem on page number 58 of the PDF version of the textbook. The problem actually states that for each of the following, state whether you expect the distribution to be symmetric, right skewed, or left skewed. Also specify whether the mean or median would best represent the typical observation in the data, and whether the variability of observations would be best represented using standard deviation or IQR. Explain your reasoning. Um, the first um, data set, the number of pets per household. Um, Second one, distance to work, and third one is heights of adult males. So number one, number of pets per household. Over here, I had to make a few assumptions because we don't really have any actual data set. So the first assumption I made was very few households will have many pets. Most people who have pets will have one or two, and many households may not have pets at all. So using these three assumptions, I wanted to kind of get a visual idea of how this would look like if there was actual data. So what I did was I used a simulated exam sampling to generate the data, and I used the R power to basically generate this random data set and basically assign it to a data frame. And then based on that data frame, I actually drew out the plot, the bar plot. And once I did that, you can see the generated plot actually shows us how the data distribution would look like. And we can see that this is right skewed based on my assumptions that I made. So most likely the data set would show us that the data is right skewed. Um, and you can see that the long tail towards the right. And then I also drew a box plot which actually shows us the IQR, the median, and then you can see this whisker on the top where this is actually 1.5 times the IQR, so it will go all the way up to 5, and this will actually describe the variability in the data because most of the data actually lies in this region here. So based on the visuals, we can see that median would be the best way to describe the typical value, and the variability in the data can be best described using the IQR. So that's part A. So now moving on to part B, distance to work, number of miles between work and home. There's a few assumptions I made over here as well. The first assumption is very few people will live far away from work, and the second one is most people will live close to their work, not more than 5 miles. Again, using the sample size of 10,000, I've generated a sample data set, using my assumptions, and I have assigned most of the people living within 5 miles from their work. So based on that, the data set that got generated, we can also see in this visual here that the data seems to be right skewed. Um, and similarly, we can see that the mean is much higher than the median because of the outliers. They're impacting the value of the mean. So over here, the same way, for the as part A, we can see the median is probably the best thing to use for describing the typical value, and for the variability in the data, we can use the IQR to describe the variability. Um, Part C is heights of adult males. In this problem, I made two more assumptions where the male height in feet are generally very close to each other. There can be male in various heights, and difference is generally not more than few inches. So they're pretty close to each other, and that's why the data set that I generated is like that. And we can see that this is more of like a symmetric, um, in basically, um, symmetric in nature. So we can see that even the box plot shows us that, and we can see the distribution being symmetrical. Uh, and the best way to basically describe the typical value here would be by using the mean. Um, and if you look at the summary, the mean and the median are pretty close. So the mean would work pretty well here. And at the same time, if we're going to be using the mean, then standard deviation would best describe the variability in this data. And this is the problem that I decided to present today. Thank you very much. Um, Bye.